I'm going to give you some tips for post-lab 16 separation of an alkane clathrate. In the first question, you're mostly just reporting data from the experiment, the mass of hexadecane that you measured in lab, and also the volume of 2,2,4-trimethylpentane that you measured in lab, and the mass of the clathrate product, and then also the mass of the guest alkane. These are all things that you will measure while you're doing the lab. For the other three, you're going to need to calculate those. The millimole of hexadecane, you're going to get that from the grams of hexadecane, converting that into moles, and then converting that into millimoles. And the molecular weight that you need is on table, or in table 16.1, which is on page 151 in your lab textbook. For 2,2,4-trimethylpentane, because that's a liquid, you measured out its volume, or maybe you just measured its mass straight on the balance. So perhaps you just have this number already written down. But if you recorded the initial amount based on the volume, then you're going to need to convert the volume into mass using the density. And the density of 2,2,4-trimethylpentane is also provided in table 16.1. So I'll just kind of add that density and then also the molecular weight. In the table, density is abbreviated with just a single lowercase d. But again, like I said, maybe you just recorded the mass on the balance, in which case you wouldn't need to do the density calculation. If you did that, if you just recorded the mass straight on the balance, you would not have anything to write in this box. You would just leave that blank. And then down here, your millimole, that you're definitely going to have to calculate from the mass, gram to mole, and then mole to millimole. For question number 2, you are going to submit the IR of your guest alkane and then identify the alkane. The alkane is either hexadecane or 2,2,4-trimethylpentane. You have reference spectra in your textbook on page 150. You could also look spectra up on NIST if you like the way that those look a little bit better. And you are going to be using your IR and the reference IR to identify the alkane. Once you know what alkane you have, you are going to calculate the amount of guest alkane that you recovered. So you are going to do this by taking the grams of the guest alkane and convert that into moles, and then convert that into millimoles. And you might be wondering, where does this number come from? Well, it's right here. The mass of the guest alkane, you're going to be using that mass to do this conversion. As far as how are you going to do this part, remember you identified whether it's hexadecane or 2,2,4-trimethylpentane. So based on whatever you decided, let's say you decided it's hexadecane, you're going to use the molecular weight of hexadecane from table 16.1 to help you do that conversion. And then the percent recovery, that's going to be compared to the starting amount. So that would be your recovered, we're going to be doing this in millimoles, your recovered millimole divided by your starting millimole, and then multiply that by 100. So let's just go with, let's say you have hexadecane, your recovered millimole, that's what you calculated in this part, that's the recovered part, and the starting millimole of hexadecane, that's this up here. Multiply by 100. Calculate the host to guest ratio of your alkane. The number, first of all, the number of carbon atoms per molecule of your guest alkane. How are you going to come up with that? Use the molecular formula. You know what your guest alkane is at this time. You've identified it. So look up the molecular formula for that particular alkane, and then that's going to tell you how many carbon atoms you have. The number of urea molecules per alkane. You have an equation to help you calculate this. It's on page 149. It's equation number 1 in your textbook in this section. And it says the host to guest ratio is ratio, not ration. Ratio is 1.5 plus 0.65 n. So this is the equation that you're looking for on page 149. And on page 149, it explains to you what n represents and how to interpret the number that you get by doing this calculation. So it's pretty straightforward, so you should have no problem navigating that. And then last but not least, you're going to do exercise 2 out of the textbook. This one is also pretty easy. It is having you compare the IR spectra of these two reference molecules, and then you're just looking for some peaks that would help you identify branched versus straight chain alkanes. There's really no wrong answer to that question.